Check 1 2. Check 1 2. Check check.
Okay, are we good? Okay, hello everyone. Welcome to Science on Tap. My name is Susan Knight. I think it's Science on Tap. And before we get started, we have a special guest who's going to give us a little announcement. And her name is Carol. I've forgotten your last name, Carol. She can introduce herself. Come on. Oh.
Where's the switch?
On the side. Oh, there it is.
Got it.
There you go.
Okay.
You can go up if you like.
I suppose. I'm not tall enough to not go up here. Woo. Okay. Hi, everybody. I'm Carol Rosenberg from Wisconsin Society of Science Teachers. I'm the historian of that organization, and it's a really fun job because I get to do all kinds of things. But just being a historian didn't give me the chance to do what I did about a month and a half ago in relationship to Trout Lake Field Station. Our organization has a bunch of awards that we give every year. Some of them are to practicing teachers, some of them are to pre-service teachers, some of them are to administrators, and one very important one is called the Friend of Science. And this is one for an entity of some kind or another. It can be an agency, it can be a museum, it can be anybody who has an interest in science education but isn't a traditional classroom teacher at any level. And I knew that Trout Lake did a lot of wonderful things because I've been a fan of Science on Tap as long as it's been around, but I've also had the opportunity when I was a regular teacher before I was retired to be in a bunch of professional development programs that crossed paths with Trout Lake. So I knew that this place had a lot to offer. So I nominated them for Friends of Science this spring, and guess what, guys? They won. So they will be receiving their official award at our conference in Oshkosh in April. Carol Warden will be the representative, and they will then have a lovely plaque from Wisconsin Society of Science Teachers to put on their wall with all the other wonderful good things that are at Trout Lake. So congratulations to our friends at Trout Lake Field Station.
All right, thank you. Here, I'll take it. And you can go this way. There's a step. Yeah. Okay. All right. And I'm going to take this opportunity, since you all are here and we've gotten this wonderful award, to remind you that it's not, usually you see Carol or you see me up here, but there are all kinds of people that are very important in putting together our Science on Tap. And let's see if I can remember everybody. But there's Amber, Amber's wave, and Noah, and Paul, Noah Lodig, Paul Schramm, who do the technical stuff, Gretchen, who is our director and at Trout Lake Station, Scott Bovey, raise your hand, and Mary Taylor, who most everybody knows, representing the alumni association, Carol Warden in the back. You all know Carol because she's up here. And who did I forget? And Peggy, who from the library, who is not here tonight, but she does a lot of work in the back. So thank you very much to all of our wonderful people who helped put Science on Tap together, and thanks again to Carol for this wonderful award. Very nice of you to honor us and to acknowledge us. Okay, all right, great. Okay, I'm going to give this back to you. Okay, so again, welcome to Science on Tap. Thanks for coming. My name is Susan Knight. And Science on Tap is an example of the Wisconsin idea, the idea that the boundaries of the university are the boundaries of the state. Our partners for Science on Tap include the Minocqua Public Library, WXPR, the Lakeland chapter of the Wisconsin Alumni Association, UW Trout Lake Station, UW Kemp Natural Resources Station, and our hosts here at Rocky Reef, and we get some of our funding from the Brittingham Fund to the University of Wisconsin. Remember, there are 3 ways to watch. You can come and be right here as you are tonight, really great. We also have live streaming you can watch from home. If we had had the weather we had yesterday tonight, we might have been doing that, but we've got good weather tonight. And you can also watch any event later. So just go to the Science on Tap Minocqua website, and that'll get you right there, and just click on Watch Archived Videos, and you'll find it. So let's get on to tonight's presentation. We'll actually first talk about next month's event, April 3rd. It's going to be all about potatoes. Potatoes are a big crop up here. And we are planning to have Becky Eddy, who's with the Rhinelander Agricultural Research Station. So that's on April 3rd. There may be a special snack to go with her presentation that might go especially well with beer. So tonight we have Dr. Grace Wilkinson, who will be discussing harmful algal blooms, why they happen, why they matter, and what to do about them. Grace grew up in Vatnace Heights, really? Pretty close, okay. Minnesota, and where she developed her love of lakes, but it was at St. Olaf College where she developed her passion for studying lakes. She earned her PhD from the University of Virginia, conducting research right up here in the Northwoods to understand how the plants on land supported the diets of animals in the lake. Another way of asking that is, are fish made of trees? Moving to Iowa for her first faculty position in 2017, she found herself surrounded by lakes plagued by severe algal blooms. Driven by the urgent need to understand their causes and find solutions, her work focuses on tackling this growing environmental challenge. Now at the University of Wisconsin-Madison, Grace uses whole lake experiments and long-term monitoring data to understand these blooms. So, we have a trivia question regarding Grace. Grace lived through the 2020 Iowa derecho in Ames. I remember that. I mean, I wasn't there, but I remember hearing about it. Peak winds of 126 miles per hour, $11 billion in damages. Millions across the Midwest were affected by wide-scale utility disruptions, residential and commercial property damage, and severe damage to corn and soybean crops. After that experience, what did Grace do? A, she moved to Wisconsin. B, she became a certified storm spotter. Or C, she watched The Wizard of Oz over and over again and named her new puppy Toto. She became a storm spotter, so maybe she'll tell more about that. And here is Grace.
Thank you. Thank you so much for that, Susan, and thank you for the wonderful introduction, and for you all being out here tonight, and those that are watching online. I really appreciate it. And I'm excited to talk to you tonight a little bit about algal blooms, which, as Susan mentioned, is something that really captured my attention, and I've been focusing a lot on since I was in Iowa. But just to get us started here, can I just see sort of a show of hands, who's witnessed an algal bloom on a lake before? All right, yeah, I'm seeing some hands up. And either, who's heard about a bloom in a lake in Wisconsin from the news in the past year or two? Yeah, I'm seeing some hands. I feel like we're hearing about blooms a lot more in the news these days. And it's certainly possible that Google has just figured out the kind of news stories I like to hear, so they're sending them to me more. I don't know if that's for you all. But as someone who really loves lakes, hearing more and more about these blooms, it makes me a little bit concerned. And as someone who studies lakes, it makes me kind of curious. And so tonight I want to talk about how blooms are changing in lakes, the negative effects those blooms can have on lakes and people, and then what we can do to try to prevent these blooms. So to start off, to understand maybe how blooms are changing, whether or not they're getting worse, we first need to talk about how blooms form, what causes them. So when I am talking about blooms, I'm talking about algae, right? So these microscopic plant-like organisms that are living in our lakes, they're in the oceans, and they are the base of the food web, right? They are doing all sorts of important things in our lakes. They're the food that our food, fish, eat, right? So really important when they're there. But when they bloom, so when blooms happen, it's essentially this population explosion of those algae, right? So just this, we call it this rapid proliferation, this runaway growth that's happening to the point of being a nuisance or sometimes even harmful. And so just to kind of get a little audience participation, warming up a little bit here tonight, I said they're plant-like organisms. What conditions do you think, or what sort of resources might algae need to have this explosive growth happen? What sort of things? Yeah. Warm. Yeah. Yeah, so warmth, and then hearing about stuff that's running off from lawns. What else? What might some of that runoff be? Phosphorus, absolutely super important. Phosphorus is very scarce in the environment and in lakes, but algae need it to grow, right? We all need it to grow. That's part of what our bones are. But algae really need it, so when it's there, they can really start growing. What else? Nitrogen, absolutely. I was hearing some whispers. Sunlight, yes, the thing we saw a little bit of today, right? Wasn't that lovely? I really enjoyed that. Yeah, absolutely, sunshine. And thinking about those warm temperatures as well. I certainly do some of my best work when I'm cozy and warm, right? So if algal cells, the warmer they are, right, they get to grow faster. And so these conditions, right, are what can lead to this explosive growth. And in some regions of the world, including here in Wisconsin, those conditions, those ingredients that can make a bloom are rapidly changing, right? So we know our temperatures are increasing, both in the winter as well as in the summertime. Both our minimum nighttime temperatures as well as daytime maximum temperatures. Precipitation, our winters are changing, right? We've had majorly variable winters here, especially over the past couple of years. And it's not just how much snow we're getting, but also when that snow is coming. And it's the same in the summer, right? We're getting these, particularly down where I am in Madison, we're getting more of these rainstorms that are really intense, way more rain happening, and that's a lot more nutrients moving off the landscape and into our lakes. Speaking of the landscape, right, we're also doing a lot to change that landscape. There's, we might be using it for agricultural purposes. There might be urbanization that's happening. There might be new human influence or inputs of nutrients, and combined with the way that our climate is changing, that's really changing what nutrients are coming off the landscape. And even things like invasive species into our lakes. Some of them are really messing with the food web and the ability of some organisms. So for example, zooplankton in lakes, which are really good at grazing on algae, and when there's a lot of zooplankton around, they're kind of like cows, right? They just do a really good job of grazing on all that algae. So when those populations of zooplankton are high, they can help keep the algae down. Some of these invasive species can really mess with how many zooplankton are there or how good they are at doing that grazing. And so given the fact that the conditions that might cause blooms are changing really rapidly, and the fact that we see them changing so quickly in places here like Wisconsin, it would be completely reasonable to expect or assume that blooms are getting worse in lakes in a widespread way. But are they? Well, it was sort of that simple, deceptively simple question that my colleagues and I set out a couple of years ago to try to answer. We wanted to know whether or not blooms were getting worse in lakes in a widespread way. And so in order to do this, what we first needed to do was define what we meant by worse, right? That's not a particularly quantitative word. What is worse, right? So what we looked at is we were trying to understand, well, what if the lake is just getting greener each summer? In other words, we're seeing the average concentration or level of algae in the lake increasing on average summer to summer. And we called that changing magnitude. So the magnitude of the bloom was increasing. But it's not just really sort of the average conditions, right? If you've ever seen a bloom, there might be one day where it's like, yeah, the lake is kind of green, and then you go out the next day and it's like pea soup, right? It's really severe. And so we were interested in, well, how is that severity, those worst days, changing? And so we looked at that peak or that severity and whether or not it was increasing. And then finally, we were interested in, well, how long is this bloom lasting? Right? Maybe if a lake often has blooms, but it was just a week, or it used to just be a few days, now it's lasting a month or the whole summer. That's going to really change the way people view that lake as being valuable for recreation, visiting, going and maybe spending money in the communities around it, right? So we called that a change in duration. So we were looking for whether or not the magnitude, severity, and duration of blooms were changing. All right, so we had our definitions. The next thing we needed to do was go find data, right, to try to answer this question. And we knew about amazing data sets, like up here in the Northwoods, folks at Trout Lake Station for the past 4 decades, in some ways even longer, have been collecting data on lakes like Trout Lake, Crystal, Sparkling, Aliquash, 7 lakes up here. Well, great, that's an awesome data set. We can use that to try to answer some of these questions, but that's just 7 lakes, right? That's not helping us get at this question about widespread change. And so we went to a database, the Lagos database is what it's called, and what that database contains is water quality monitoring data from state agencies, from cities or counties that are doing water quality monitoring, from a lot of volunteer water quality monitoring programs as well, and brought it all together. This was work by other scientists in bringing this together and making it available for us to use. And so from 14 states here in the Midwest, as well as in the northeastern United States, we were able to find 323 lakes that had measurements of how much algae was in the lake in the summer that we could use to answer this question: how are lakes changing? And the key thing is that these time series, or these data sets, looked back in time 15 to 20 and sometimes even 30 years. So we weren't just interested in sort of how was the lake looking last year and then now this year, these short-term changes, but really wanted to understand how these longer-term trends were playing out. So that long-term window was important. All right, so we're at 323 lakes. How are blooms changing? Well, we found that about 11%, or 1 in 10 lakes, were getting significantly worse. Either the magnitude of the bloom was increasing, the severity, or the duration. So about 10%. But surprisingly, we found that 17% of lakes, about 1 in 6, were getting significantly better. And the other 70% or so of lakes really hadn't changed in this window of 15 to 20 years. And I have to say, maybe this is not cool to say as a scientist, actually I hope we can admit this, but I've never been so excited to be wrong about a hypothesis, right? Sometimes when you work in environmental sciences, you're used to sort of the more doom and gloom story, right? So we were really interested in figuring out, okay, what is it about this 17% of lakes? Why are they getting better? What could we learn from those lakes to maybe try to apply to help these 10% of lakes that are getting worse? And so there was a lot of different ways that we looked at the data, but one thing that seemed to become clear is that what we might be seeing is the benefits of the Clean Water Act starting to play out. So the Clean Water Act is a piece of federal legislation. It requires that our surface waters are monitored for water quality and meeting whatever state standards have been laid out. And if they're not, they can be listed as impaired, which creates an opportunity then for studying the problems in that water body, let's say a lake, more, and putting resources and effort into trying to address that problem, whether it's nutrient pollution or something else. And so what we were interested in doing is seeing, well, have these lakes essentially been subjected to some restoration efforts because maybe something was happening and that's why they were getting better? Unfortunately, there is no federal or even state database of restoration activities that occur in lakes and other water bodies. And so we were thinking, well, how are we going to figure this out? And what we ended up doing is we went to local media. So local newspapers, TV stations, radio stations, and it turns out if you are a lake association or a city or a county that's about to invest a ton of money in doing a lake restoration, you tend to put out a press release and you want people to know about it, right? How their taxpayer dollars, how those funds are being used. And so we combed through local media as best we could with these lakes that were getting better to try to find if there was evidence that restoration had occurred. And we found at least 2 out of 3 lakes that were getting significantly better had had some form of restoration occurring during the window of time that we were looking at. And so, you know, that's not conclusive evidence, but it seems to hint towards this idea that we know that we have these big environmental problems that are complex and really tricky to be dealing with. And that there are ways, at least in these lakes that we were looking at, where people and their interventions were turning the tide or the trajectory, potentially, of what was happening in these lakes with regards to blooms. But there was still those 10% of lakes that were getting significantly worse, right? And so perhaps maybe a question to ask ourselves then is, well, why does that matter? Why does it matter if blooms are getting worse in lakes? So blooms can disrupt ecosystem services, or we can think about those services as the benefits that we as humans get from nature. So for example, if a lake or a reservoir that's experiencing blooms is a drinking water source, it can disrupt the ability for that water to be a drinking water source. Clearly that's not the case up here in northern Wisconsin, but in other places in the United States as well as around the world, that's a huge problem. It can disrupt recreation and tourism, right? People wanting to come and recreate on that water body, spend money in the local communities. If that lake's really green, that might not be a place they want to go. They might select another location. And as blooms, they grow. It's this massive amount of algae. When that algae dies, it starts decomposing, right? And the bacteria that are decomposing it are consuming or using all the oxygen in the water. And that can, when there's really, really severe blooms, potentially even lead to fish kills in the summer, in the most severe. That certainly happened on some lakes in Iowa that I studied. But one of the other major concerns that folks tend to have about blooms are the toxins that can be produced by bloom-forming cyanobacteria. So cyanobacteria are also that plant-like in terms of they photosynthesize, right? They're bacteria, they live in the water. You might have also heard them described as blue-green algae at times. Yeah. They're not technically algae, they are bacteria, so we'll call them cyanobacteria. But they get that name because of that sort of blue-green color that they have. So cyanobacteria evolved about 2.7 billion years ago at a time when Earth didn't have any oxygen or very little oxygen in its atmosphere. And let me tell you, cyanobacteria did not care. They just started photosynthesizing, producing oxygen through that photosynthesis, and are responsible for the wonderful oxygen-rich air and atmosphere that we are breathing today, right? They first evolved that. And let me tell you, these are scrappy little survivors, right? So there's not enough nitrogen around to grow, doesn't matter, no problem. Cyanobacteria have figured out a way to harvest it out of the air, out of the atmosphere. There's, for example, not enough sunlight for them to grow. Not a problem. Cyanobacteria have these special things called gas vacuoles that allow them to adjust what depth they are in the water so that they can get more sunlight. There's, say, a lot of those zooplankton grazers around trying to eat them. Not a problem. Cyanobacteria, they make these globby colonies and cells. They make these long filaments that are just impossible for the zooplankton to eat. So if all of the conditions are ripe for a bloom to be happening, all those conditions that we talked about, cyanobacteria, if they're present, are really good competitors and can potentially win. But another special thing that cyanos do, or cyanobacteria, sorry, I used to call them cyanos, is that they produce toxins. And if in really high concentrations and ingested, those toxins can at times be harmful to humans, pets, and wildlife. I think it's really important here to note that, first of all, not all cyanobacteria produce toxins. Not all cyanobacteria that can produce toxins do so all the time. And not every bloom is a cyanobacteria bloom, right? So I think when we think about toxins, like that word brings up a little bit of fear, and like for good reason, right? But it's important to kind of understand what that risk or space is, and it's not in every bloom every time, certainly sort of thing. But for those blooms that or for those cyanobacteria that do produce toxins, one of the most common ones is called microcystin. It's actually a class of toxins that has over 300 different types. And the thing about microcystin, it's what we call a hepatotoxin, or in other words, it does damage to the liver. But the most common symptoms that people report when they've ingested water that has microcystin in it are things like headache, vomiting, sores, and abdominal pain. So those are the more acute symptoms for the low exposures that people tend to get if they are exposed when recreating, which is not a particularly common thing. So part of the research in my group is trying to understand, okay, well, if these toxins are being produced and they're in the environment, how do they move through the environment? Where might we find them? In an effort to try to understand if and when humans might actually be exposed. Because if we can understand those things, then we can understand how to protect humans and pets and our wildlife, right? So that doesn't help you, though, at this moment, right? And saying, okay, well, I showed up at the lake, it's looking kind of green, I don't know what to do. So ways to think about some sort of common sense ways to protect yourself or others are thinking about like, okay, it is really green in that water there. Maybe I won't get in and swim in that particular part of the lake or today, right? Common sense. I'm not going to drink that water. I hope these seem all adults in this room. You have a pretty good sense of what water you should and should not be drinking, yeah? But I guess think about it from the perspective of a kid or a dog. I swear, every time I take my dog to a lake, it's like she's never drank water before, and this is her first time seeing it, right? And so while I really love Piper, right, she's not so smart in what she should or should not be drinking. And so that's one of the things I always keep an eye on as well if I bring her to a lake. And then it's also things like if you do decide to swim, just taking a rinse-off shower. So cyanobacteria, as well as a number of other algae, produce things called polysaccharides, and they're really irritating to our skin. And so, but taking a quick rinse-off shower is something that just prevents that. So you might be thinking, okay, well, there's some lakes that are getting worse, some that are getting better. Clearly, blooms, particularly cyanobacteria blooms, are not something that we want to mess with. How do we prevent these? Really, what's really critical, and we talked about all the ingredients that can lead to a bloom, is preventing in particular the nutrients, or what we call eutrophication, that enrichment in nutrients from happening. Preventing or reversing where eutrophication has occurred. The tricky part about that, though, is that once nutrients are on our landscape, when they're in our waters, there's this long legacy. In other words, they stick in those soils or in those sediments for a long time and are periodically released. And so it makes it kind of a tricky problem. We can take action today, but we might not see all of the benefits of our action, say by stopping nutrient pollution, for a number of years or even decades, the true benefit of all of that. It's a long and sticky problem, but it's a really important one. So we can act thinking about sort of at the watershed scale, right? But that's a lot of different landowners and land users and sort of quilt or puzzle pieces of a bunch of different policies and laws in our different municipal governments. But there's ways to act there and have collective action. But there's also things you can do as an individual and be better stewards of your waters. So one thing I think of up here in northern Wisconsin is thinking about maintaining your septic system. Making sure that that septic field, that you're keeping good maintenance on that because human waste has a lot of nutrients in it. Planting native riparian buffer and restoring shorelines along lakes is a great way to try to prevent those nutrients from getting into the lake in runoff, a sort of last line of defense, but it also has all these other wonderful benefits for our wildlife, pollinators, and things like that. You can volunteer to be a water quality monitor. The type of data that I talked about at the beginning where we were looking at these long-term trends, a lot of that came from volunteer water quality monitoring and was so critical for understanding how those individual lakes and lakes regionally are changing and responding to these big global pressures, climate change, eutrophication, land use change, and things like that. And that helps us manage both at the individual lake level as well as policy at a higher level. So critical. So important. And have a conversation with your neighbors, right? Take maybe something you've learned tonight or something else that you know and go and talk to folks about it. Because when neighbor to neighbor to neighbor starts happening, that's when we start getting bigger action occurring. Some of the other work that we're doing in my group, though, thinking about from this prevention side, is Susan mentioned that we do these whole lake experiments just a little bit farther north here, just over the border in the Upper Peninsula of Michigan. And there we're actually trying to cause algal blooms. So we're doing nutrient additions, trying to cause these blooms. But the reason why we're doing that is because we're trying to test and develop tools to predict when blooms are going to happen so that we can try to intervene, prevent them from happening, or use it to protect people. Maybe that's when we start monitoring, for example, for those toxins in the water. And we're also doing it in an effort to enhance resilience. In other words, can we make the system, the lake, the ecosystem more resilient to that nutrient pollution? All of those different things like those grazers that I talked about that are so good at eating algae, are there ways that we can enhance what they're doing to prevent those blooms from happening while also not messing with the ecosystem by adding a bunch of other types of chemicals or something like that to prevent or stop the bloom? And speaking of those sort of other chemicals and things, there's lots of technologies out there, and I'm guessing some of you have heard of a lot of these or maybe have questions about them, and I definitely want to talk. There's a lot of different ways that folks have come up with for trying to stop or kill harmful algal blooms, and I'd love to chat about them. But I think when we're doing so, we need to keep in mind and be careful not to be using those technologies as Band-Aids without addressing the root cause of the problem, which is nutrient pollution. It's this eutrophication. And so One thing I really hope that you take away this evening is that in order to protect our lakes, we need to continue to reduce eutrophication, promote and do restoration, and adaptively manage in the face of a changing world. And I'm going to leave it there, and I really look forward to our discussion and any questions that you have. Thank you.
Amber is walking around with the microphone, so raise your hand and she will come to you.
Thank you. Good evening. Thanks for coming to see us. I'm part of a lake association, so if you're familiar with that, in Wisconsin, it means we have zero power. No policing power, nothing. So if we, during a yearly meeting, if we want to do a little education, give me some practical things to talk to my neighbors about.
Yeah, that's a great question. So I think kind of returning a little bit to the items that I mentioned, but also if others have other ideas, I welcome that too. So I think in particular, I mentioned the septic systems, really thinking about shorelines and what people are doing on their properties leading up to the lakes and in the lakes in terms of their dock lines and whatnot. There's a ton of benefit, we know, both in terms of shoreline riparian buffer in being, and so what that means is plants that are planted there as opposed to not using, for example, grasses all the way up to the shoreline. Even those sort of buffer strips can be beneficial in preventing additional nutrients from getting into the lake. It's not foolproof, but it certainly does a lot to prevent, with all the other benefits that I mentioned in terms of for pollinators and wildlife. They're also just really beautiful as well. But that's also another thing in thinking about, for folks that do have lawns, don't fertilize. If you are going to fertilize smart, right? Much lower amounts, doing it at a time when there's the opportunity for the plants to actually take it up in a rapid manner, and not before the thunderstorm that evening. But and then I think another really critical thing that's probably, I'm guessing, on your Lake Association's mind is really thinking about the spread and prevention of invasive species and not having compounding problems of what's happening in the lake. Those are just some things that come to the top of my mind, but if others have ideas, I'd welcome them as well. Yeah, thank you for your question.
I was just going to add real quick, the DNR has wonderful pamphlets too that you can pick up and give out to your association. That really helps.
Yes, thank you for mentioning that. There is a wealth of information that the DNR provides, and that there's just a great place to start, as well as I think there's opportunities for supporting actions that lake associations can take, some grants that can be applied for as well.
Hi.
Yeah.
If you were out to grow a bumper crop of algae,
Yeah.
would like brackish, swamp-covered backwaters that with a lot of tannins be favorable to that more so than a clearer lake? Or, because you see them growing on clear lakes a lot, but I'm just wondering, we're covered with all kinds of backwaters around here of sorts. Are they really favorable to that, and how are they influenced by runoff? Because they're usually surrounded by woods.
Yeah, that's a great question. So I think a couple of components to that there, and I don't want to speak broadly to like all backwaters within this region, but just some things that immediately came to mind. So we do, because of, for example, you mentioned the surrounding forests and a lot in this highly forested area, we don't have a ton of direct nutrient input. There certainly are places where that is occurring. However, that sort of tannin-rich, really, it's organic matter, has a lot of organic phosphorus and nitrogen that's along with it as well. And so there's been some interesting studies where they actually tried to increase those tannins in a lake, expecting that would block more light, right? And so light is one of those critical ingredients needed, and that would really tamp down the amount of algae that were being produced. And what they actually saw was it actually created a little bit of a boost or an increase in the amount of algae that were in that lake. And the reason for that, they found, was because of that nitrogen and phosphorus that was coming along as a part of that organic matter. So I give that as an example simply to say that it's kind of a complex picture in terms of where those nutrients are coming from. I might also think about shallow waters having the opportunity, with the dark sediments being so much closer, getting a lot more light or heat that might create a little bit warmer waters that are easier for those algae to grow in. And so I think it's a little bit of a mixed bag in terms of whether or not that would be a place where you'd get more algal growth versus in the clear lakes where you do have a lot of those light, might be more nutrient poor though, right? So. Yes, the question was about cyanobacteria in that same environment. Yeah, so cyanobacteria, if they've been present, they're really interesting. They create essentially this sort of resting stage that can be on the sediment of the and when better conditions, warmer, more light comes along, they essentially hatch back up. So it's like a seed bank in the sediment, but for these bacteria in these resting cysts. And so it's certainly possible that you could, have had cyanobacteria in the past. There's that essentially seed bank in the sediments, the right ingredients or conditions come along, and you get a little small bloom that comes up from that. But you really have to have those right conditions. They might germinate as those seeds, but if those conditions don't last long enough, they're not going to stick around or cause too much of a bloom. So I think the unhelpful but answer to your question is algal growth is so dynamic in time. We can be talking about from hours, days. When we're experiencing blooms, it's usually days to weeks. But it's also being affected by things that are happening, like nutrient pollution, on even longer time scales, years and decades. And so that's what makes it interesting as a scientist. It's really hard to predict, but really frustrating as somebody who's trying to enjoy those waters. So thank you for your question. Yeah.
Thanks for being here. We lived on the shore of Lake Winnebago for a long time, and we had algae bloom that was unbelievable. Ducks walked on it one year at a marina.
It was sand.
Yeah.
Oh my.
Now, does the phosphorus go away, or is it always there once it gets put into the water? That's my question.
Yeah, excellent. The tricky thing about phosphorus is it's pretty sticky. So phosphate is a molecule, particularly when there's iron around. We have soils that have a fair bit of that. It can get bound to that iron and stick around. And so it can take a long time to leave the system. We tend to think about this, we call it the resonance time. So on average, how long is a molecule of phosphate, once it makes it into the lake, going to stay in the lake before it leaves? It's not quite the same thing as asking how long does a molecule of water, of H2O, when it comes into the lake, stick around before it leaves, because phosphate can get taken up by those algae, it can bind to the sediments, so it sticks around for longer. And so that's part of, and then it can be released. That's part of this tricky problem, because we can have phosphorus that came into the lake decades ago, but that is being released from the sediments and fueling maybe the bloom that we're seeing now. And so that's called internal loading, and it creates this really long memory, or essentially legacy, in the lake of phosphorus pollution from the past. I have a colleague down at Wisconsin who did an interesting study on Lake Mendota. And what they found was that if we stopped adding phosphorus to Mendota today, it would take about 100 years to get back to, based on modeling that he was doing, to get back to those really, really clear waters. We'd see a lot of benefit in the first decade or two, but to get back to those kind of truly clear waters would take about 100 years. And Winnebago's tricky because it's also a very shallow lake, right? And so it has a lot of water cycling and movement and a lot of kicking up of those sediments. And so that the interaction between the sediments and what we call like the water column there in shallow lakes is tricky. This is something we dealt a lot with in Iowa too, big shallow lakes. Yes, a lot of muck, yeah. Apparently ducks walk on it. Oh, wow, I'm gonna think about that, thank you. Whew. That's thick.
I've got an online question. What are the implications of drawdowns on nutrient levels?
Water level drawdowns. Yeah, that's a great question. It's a little bit totally outside of my area expertise, but I'm gonna answer a little bit with what I know. So part of what that can do is disconnect, at least for a little bit, the sediments from the water, right? Because they've been drawn down and dried. It compacts those mucky sediments, which can potentially be helpful. But one thing that I know, and why it was used as a strategy for a lot of reservoirs in Iowa that were shallow, is doing that drawing down in the compaction of the sediment allowed aquatic plants, so macrophytes, aquatic plants, to be able to germinate and take hold. And that's really helpful for keeping those shallow sediments in place, not allowing what we were just talking about for Lake Winnebago. And so that can be really beneficial if there's those aquatic plants there to take hold. So that's kind of one way to answer that question, but nutrient cycling is complex. Yeah.
Experience at the smaller pond level, I've known that like putting in a log will like prevent algae growth in a pond. Wondering at the lake level, does this like affect the nutrient cycle? Looking at the shorelines of like possibly deadwood falling in, does that help a lake? Do you familiar with that in the nutrient cycle?
Yeah, so tell me a little bit more what you're talking about in the ponds in terms of, just so that I'm understanding.
I've just seen where you put in a dead log and let it float in a pond, it'll prevent algae from growing. I don't know if it's a carbon balance or something off the log, but
Curious.
It works at a small scale, for sure.
Yeah, that's curious. I haven't heard about that before, but I'm wondering, thinking about like tannins that might be coming off of that, well, with the decomposition or the way that nutrients are cycling. Yeah, so I guess I haven't heard about that for the larger lake scale, but I think your intuition is right. Then when we're talking about, in this instance, you were talking about the log versus the volume of that pond. When we get up to larger volumes, we have usually bigger watersheds, so more nutrients coming in, as well as, not always, but a longer residence time, like I was talking about, of those nutrients. And so it takes a lot more energy or effort put in to reverse that eutrophication. So I think that your point about volume makes, but that's a good question. I'm going to think a little bit more about that in terms of deadwood falling. Great fish habitat, right? Amazing for that, absolutely.
I've heard the term red algae bloom. What is it?
Yeah, so thinking, Yeah, so like red tide, thinking about it. So that tends to happen in our coastal waters, and that's a different form of algae.
I've heard it in inland lakes, especially around like Madison area.
So there are things, I haven't heard about them in Wisconsin. There's golden algae blooms, but maybe with this, is it something that's happening more in like the winter? You think?
I guess I can't define it, but I've heard people say around Madison, just Madison Lake, so red algae bloom. I guess I
okay.
can't.
Yeah. I'm like trying to pump you for
I don't know.
information when you're
I don't
asking me
know.
questions.
They just call it a red algae bloom. I don't
Yeah.
know if it's
So,
correct environmentally or not.
yeah, well, a couple of things that come to mind is, so there is a cyanobacteria that does have a much more reddish or pink kind of pigment. And Planktothrix rubenescens, that rubenesque, right, like being that sort of red color. And it lives even deeper in the water, where it can get some more nutrients from lower and can deal with that low light. And for example, one time when I was in Iowa, we drilled through the ice, pulled it up, and it was like a pink slushy, this pink-red slushy under the ice. And it was one of these Planktothrix blooms. And it's because they could handle the very, very low amount of light that was coming through the ice, right? So it's possible that it's something related to that. There's also, there's other bacteria that aren't, they're like called purple sulfur bacteria, and they can bloom all of a sudden and come up. Trying to think about what else this might be related to. Sorry, the other thing I wanted to mention, you know how I said not all blooms are cyanobacteria blooms? So a very common thing that happens in lakes in this region is that there's the springtime, it's nice cold water, it's a lot of nitrate that's coming off of our landscape, and diatoms, which are another algae that can have sort of this brownish red if they're like really blooming. So that might be maybe what it's related to. Those diatom blooms can really come on. And you kind of see it in the lake. It gets a little greenish, there's some brown. They're beautiful. There's shells. They essentially have these shells that are made out of silica. They're just gorgeous to look at under the microscope. And they're really great food for Daphnia. So those cows of the lake, right, that are grazing. And so then those Daphnia will hatch out. They'll start eating all of that diatom, and that's when we get, maybe you've heard about the clear water phase, or that time usually in sort of June where we get nice clear waters. And so I wonder if maybe that's related to it. But if others have idea about what that is, I love learning more, so please share.
My question is, I used to live on Big Arbor Vitae Lake, and I don't know if any of you guys have seen pictures of it. It was completely green this summer, starting in July. Nobody could be on the lake. It was dangerous, and it was from the algae bloom. So my question is, why and how did that happen?
Yeah, that's a great question. And then another back to that, you mentioned it being like no one was out on the lake and the danger. Was there like sampling that had taken place by the county or someone that?
I know that there was an issue in the past, and they thought that there's like a people that live there like temporarily, camp, whatever, and they said that all the sewage was flowing into Big Arb, and then they had to redirect the water. I used to be on the lake association there before I moved. But that's why they said there was an algae bloom, because there was sewage flowing into the lake.
Yeah, I don't know in this particular instance, but that's certainly, like I mentioned before, human waste, we actually have a lot of nitrogen and phosphorus in what we excrete on a daily basis. And so that can be a large input if that's not managed. This is why we created wastewater treatment plants, right? This is why secondary treatment was required and part of the Clean Water Act. Right? Good stuff. Our rivers aren't on fire anymore. We're seeing benefits. And so I don't know in this particular instance, so that's possible. But yeah, if you have a lot of nutrient input gosh, yeah, that's wild. That's really tough. And I think Little Arb sometimes gets somewhat green. I remember that from when I was sampling up here during my studies. Yeah, that stinks. I'm sorry. And it probably actually really did stink.
I've got another online question here. Could slowing down flow of water in lakes by raising water levels with downstream dams cause blooms?
Yeah, so one thing that's slowing, certainly it's possible that it could contribute. If there's other nutrient pollution, there's enough of that warm water and sunshine and things around, right? So we need to think about what those ideal conditions are. But as I mentioned previously, talking about that residence time, if by slowing down the water, essentially you're creating a longer residence time, that can mean that nutrients are spending more time. So the possibility, certainly. And when those dams get put in place, it tends to flood. Right, so you have flooding of shallow, what was previously land. And so there's going to be residual nutrients in as that decomposition is happening as well. So certainly a possibility, yeah.
A lot of us up here came here to get away from all of that stuff. But my question is this something that's expanding in the state or regressing or what?
Yeah, so I'm going to approach that from a couple different angles. I'm going to tell you from our study, we had a number of lakes in Wisconsin when we were looking at the near recent past. Most of them were either not changing. There were even a few up here who had those trends towards getting better. And there were some in particular, like down in the southern part of the state, where they had the trends in the opposite direction, where we're actually seeing that there's a lot more heavy and extreme precipitation, or those rain events that are happening in the summer, bringing a lot more nutrient in. And that's what we really tied to, for example, in Mendota, and the way the blooms that are changing there in that lake. And so that's kind of retrospective. If we think and look into the future, like I mentioned, temperatures are getting a bit warmer. How long our winters are lasting, when they're sort of happening and how we're experiencing them, is really essentially the number of days that ice isn't on the lake is how much time we're getting more sun or that solar radiation that's heating things up, right? So it's really changing in that seasonality. And there has been from others in their work showing that maybe if very, very cold waters, like in Lake Superior, that are extremely nutrient poor, maybe if they're warming up a little bit, that could be helping with some algal growth, but I don't think that's what we're currently seeing here in our lakes. But the best way to buffer them against any changes in climate that are not things we're going to have individual control over are doing what I mentioned and really trying to tamp down on nutrient pollution and put in those restoration and conservation practices is the best way to buffer now and into the future. So I'm sorry, that's not a particularly satisfying answer to your question, but that's what I'm offering right now.
I just had a question regarding boat traffic.
Yeah.
So has there been any studies, or have you thought of studying lakes that have more boat traffic if they have more blooms?
Yeah, that's an interesting question, and I am aware that some folks are currently working on questions about that and thinking about how sort of near shore and just wakes from boats might be influencing, for example, the way that nutrients in the sediment might be coming up into the water and could help stimulate blooms. I think that's in a really early stages. Kind of tricky to also think about. I think lakes that people like to spend a lot of time recreating on and they have their boats on are also places where people are often, and so we might be having more nutrient pollution. And so that's why these studies that folks are doing, trying to really get at, okay, is it the boats? Is it other things that might be providing those nutrients? So there's certainly a potential mechanism there, but I think it's still very much a question. You stir up the sediment, might release some nutrients, but sediments are pretty heavy. They also sink out again pretty quickly. So it might matter something about the frequency with which or how often that stirring is happening, but also probably a lot about the aquatic plants that are growing in that area and protecting them. They do such a great job of keeping those sediments down and controlling. And so that's a really critical portion of that as well. So again, I don't have an answer, but I know it's something that people are looking into, not in my group in particular, but that's a really important piece of information as we're seeing more and more boat traffic on our lakes now. Yeah, especially.
I was wondering if you could speak to the effects of a few kind of new things that have come up as far as that might be affecting algae bloom or may not, I don't know. But wake boats, permanent piers, and the tendency to have lights on the water now, like.
Yeah, so thinking about like lights at night or whatnot. Yeah.
You know, a lot of people are starting to put them on their shoreline and on their pier and.
Yeah. I'm not aware in particular of any studies that have linked that sort of nighttime light and light pollution to algae growth or dynamics or what's happening. There has been some really interesting work in thinking about for animals in our lakes that really require that darkness or, think about when they're hunting or at night and trying to find their food and effects that might be having. So that sort of nighttime light pollution, but I'm not aware for anything with algae. Similar with permanent piers. You asked about another one. Oh, in terms of the wake boats. Yeah, so again, I know that folks are working on trying to understand what that sort of power in terms of wave force and wake is having and how far that effect is, which also interacts with how sloped the shoreline is where that wake is meeting it, right? In terms of what that nutrient release might look like. And I think a really important thing that we need to keep in mind when we're doing all of this is where I put on sort of my systems hat, right? Is thinking about, okay, that's maybe one potential source of nutrients. Where are the others? How do they compare both in magnitude as well as in time? So there might be a lot of phosphorus, for example, that can blow through as the snow is melting and move through the system. But if it's nice and cold, the algae aren't necessarily going to be ready to take that up and grow. So sometimes nutrients matter both in terms of the amount and the time that they're available. And so for all of these questions, these are great questions that you're asking. We want to also put them in the context of everything else happening in the system to understand how blooms are responding.
Yeah, because I was wondering, because it seems like the permanent piers keep a large extent of shoreline and water open for extended periods, like all winter, and so lights coming in, and I don't know if it, I just wondered.
Yeah, so thinking about that too, and light under the ice as well as when there's not ice cover, because in these areas can do all sorts of things to both the aquatic plants as well as algae that are growing there. But then thinking in that instance, the really cold waters, so something like cyanobacteria are very unlikely to be thriving, and that's where you might see more of those diatoms that are kind of the delicious candy for the zooplankton and things. So again, it's both timing and magnitude. It's a really interesting question. Thank you.
You mentioned domestic dogs being susceptible to the drinking from the lakes like that with the blooms. What about non-domesticated animals, wolves and deer? Do they have signals that prevent that, or?
Oh, fascinating. I don't know, but I would love to learn if they did. Yeah, that's really curious. And I think animals do have a lot of adaptations in the way that they think about how they find water sources that they're going to use. So I think about, for example, I think it's pretty common for felines and I'm sure other mammals as well to be looking for essentially moving water, right? So thinking about that there's going to be less stagnant water. It's not the place to drink necessarily. One thing I will note is that it was a completely different kind of cyanobacteria, but in Africa, this was back in 2018, Botswana. There was watering holes that had a lot of nutrient input from animal dung. These massive cyanobacteria blooms that they confirmed by satellite, and there were a number of dozens of elephants that died. And they finally actually confirmed just last month that was from cyanobacteria. But that was a very rare circumstance and not things that we are seeing here. I don't want you all to oh my gosh, it can take an elephant. Right, but yeah, so absolutely. And that's, I imagine in that instance, that might have been one of the few water sources available. So then it's also a matter of choice for those animals too. But yeah, that's a really curious question. Thank you.
I've got another online question. Is there a way that the general lake users could tell or get an idea if it's a toxic bloom or just a green algae bloom?
Yeah, oof, that's a tricky question. That's the million bajillion dollar question, right? Yeah, so that's the tricky thing. Even under a microscope, if I'm looking at cyanobacteria under the scope, I can't tell whether or not that cell has been producing toxins or not. It's something that's completely within the cells. And so there are certainly some maybe signs that it could be a cyanobacteria bloom, so you might want to exercise additional caution, but without the direct testing of that water sample, you don't know for sure, right? And so some of those signs, I mentioned that microcystin is one of the class of toxins. It's named after Microcystis, the genus of cyanobacteria it was first discovered in. And if it's a Microcystis bloom, it looks like spilled green paint on the surface of the lake. You don't tend to see that with green algae blooms. You can see lots of that. For example, we added nutrients to a lake up in the Upper Peninsula. We didn't get a cyanobacteria bloom this year. It was a nice, beautiful, rich green algae bloom, right? All algae love to bloom if you give them the right ingredients. And so it's that really sort of paint spill. Another one that is called a phanozomenon, which is really fun to say. And that one looks like tiny grass clippings throughout the water. And so this is sort of the two of the ways that you can tell, but mostly it's just about exercising caution. And without a direct sample, you don't know whether or not toxins are being produced, unfortunately.
Of your 323 lakes, is there any correlation based on the size of the lake?
Yes. I'm so glad you asked that. In fact, so we were looking at lakes that were quite small. So like the size of like a hectare, so like really small up to a few square kilometers in size. So like Mendota was a part of that and even bigger. The bigger lakes tended to be the ones that we were more likely to see a worsening trend, not necessarily significant, but a trend where some of those metrics were getting worse. We also tend to put a lot of human activity and build houses and communities around bigger lakes, so there might be a little bit of a correlation there. But interestingly, another study that actually was the reason why we did ours is they had just looked at big lakes across the globe using satellites, and they were saying, well, in these big lakes, it's getting worse. And I was like, well, what about the tiny lakes, right? Someone must speak for the tiny lakes, and it turns out across the globe, tiny lakes absolutely, in terms of numbers, blow big lakes out of the water. We just have way more of them. And so if you sort of stretch that gradient from small to big, there's maybe some evidence that the bigger lakes are more likely to be seeing some worsening blooms in those metrics, but again, that's definitely that could be a part of having more people around them. More people also means we measure them more. So we need to also think about why those 323 lakes had that water quality monitoring happening and not the tens of thousands of other lakes we have in the region. So there's definitely still, I think even more questions than answers in that regard, but thank you.
I'm wondering if you could talk about if there are any lakes that are just kind of unlucky, Like those lakes that are in the middle of the woods that are always green, and what's happening there?
Yeah, that's a great question. Did you have a specific example of one?
I guess one that comes to mind is Little John. I mean, it's basically completely surrounded by forest, and it's almost always green. I don't think it's cyanobacteria, but
Yeah.
you know, the buzzword of internal nutrient loading and what that means and why it happens to just a select few lakes, it seems, compared to all the other neighbors it has around it.
Yeah, absolutely. So, yeah, that internal nutrient loading that Carol was mentioning and I talked a little bit about earlier is nutrients that are stored in the bottom of lakes and the sediments that are periodically released. And again, with the phosphorus, the key thing here is that if there's oxygen present, that phosphorus is going to be bound to the iron. So the way I teach it in class, when oxygen's around, phosphorus is bound, right? And then when that oxygen is used up because of decomposition in the bottom waters of lakes, then that phosphate can be released. Now it's sitting there as dissolved phosphate in the water, but it's down at a part where there isn't any light, right? So the algae aren't going to be able to take it up and use it to grow unless that water column mixes, right? So lakes, deep water lakes, many lakes around here are usually stratified in the summer, right, where there's the warm upper layer, then this sharp change in temperature and density, and then the deep water. And so it's possible, I don't know for Little John specifically, but you can get instances where you get just a little bit of essentially that mixing or leaking that's happening. That stratification, we like to talk about it as being sort of this like solid layer. It's sloshing around like this on big lakes when we have wind and things like that, and that can cause some messiness in coming up. Once a lake has a lot of, for example, you get that bloom that's essentially happening, then all that organic matter, that algae is dying, it's decomposing, it uses up the oxygen, and it can essentially create this cyclic or perpetual bloom phosphorus cycle loading that's happening. I don't know if particularly that's what's happening on Little John, but this sort of runaway cycle can certainly happen, and we see it a lot in very nutrient-rich lakes. Even if we stop adding nutrients or nutrient, management happens in the watershed, that they're just going to keep going in that cycle for many, many years or decades. And so another, even in the most remote places, there's a lot of dust that gets deposited, and there's also deposition of phosphorus in dust as well as nitrogen deposition. And so there's been some studies showing up in sort of the Arctic and those reaches that there might be some important nutrient inputs coming from the atmosphere that could be stimulating as well. That's clearly a little different than the Little John story, but it's a good reminder that our human actions and activities have very far-reaching consequences. Yeah.
Just wondering about fertilizers and things that we do on our lawns or on golf courses and how that all feeds into our water system and affects our lakes and land.
Yeah, it definitely does. Was there any part in particular about, or just sort of like in terms of the application or the
phosphates and everything that feeds into our water system?
Yeah, absolutely. So any of those additional nutrients that we're putting on land, and for many reasons, for good reasons, right? Fertilizers help us grow, crops, food that we need to grow, food for our food as well. But so it's the excess that's really a problem. And when we have, so speaking, for example, in agricultural systems, when we have incentives and an economic structure in such a way that we really need to intensify every single acre and the yield off of it, that, a little of that extra nutrient helps with that insurance when you're trying to live in the margins. And so it's a really wicked problem because it's not just, we know the answer. Eutrophication is what underlies blooms. Okay, let's stop that eutrophication, right? It's not just a science or an aquatic science problem. It's a human problem, it's a human systems problem, and all of those different things need to come together in order to address it. And so some things individuals can do, particularly when we think about nutrient inputs, maybe don't. But also, if you can prevent it on your lawns and things like that, thinking about moving to native vegetation where possible, and also if nutrients are put on or fertilizers added, doing in low amounts and in the right timing. Right timing is everything, as we've been talking about for nutrients, can really help in sort of that precision in decreasing the amounts that are needed.
Since septic systems are one of the causes, is there any way to do aerial pictures or something to determine what systems are leaking into the lake?
That's an interesting question that I am not sure. I don't know, but it's possible that that could certainly be one way to look at that, or assessing. Getting people on board for doing those assessments and maintenance would be another way, so sort of from the ground up as opposed to that actual top down. But that's a good question. I don't know the answer to that, but I'm going to look into that. Thank you for asking. Amazing.
Okay, can we all give a good hand to Grace? Thanks very much.
Thank you so much. Thank you.
And thanks. Remember, our next Science on Tap will be on April 3rd, where we will hear about potatoes with a special snack with Becky Eddy of the Rhinelander Agricultural Research Station. Please sign up for emails. There's a clipboard right by the door. And thank you for coming, and we'll see you next month. And thanks again to Grace.